Good morning, ladies and gentlemen. Today I am at Cedar Point with our physics and calculus students. So you should be in Mrs. Richards' room, and Mr. Hartley should be there with you. I will check in your homework from Friday, which was page 634 to 635, 6 to 18 even, when I see you tomorrow, which would be Tuesday. Today you will be watching this video and filling in your notes. Mr. Hartley should have given you your notes. And we'll go ahead and fill them in, and then I will assign you homework when we're all finished. So here we go. Probability. You should be able to give me by now a definition of probability. Probability is the likelihood of an event occurring. Okay, how certain are you that the event will occur? And in order to calculate that, you have to make a fraction. You do your number of favorable outcomes over the number of possible outcomes. Today we're going to be talking about the complement. Now we talked about complement like way back in September. Okay, complement is basically saying something will not happen. So the probability of an event not happening, sometimes it's written with a little apostrophe like that. And in order to calculate it, you're going to do 1 minus the probability of an event happening. So basically, you're going to subtract off every time it does happen. And if you want to use the notation with the apostrophe, it's the same thing. Okay? The probability of an event not happening is 1 minus it actually happening. Okay? So let's take a look. You are dealt 1 card from a standard 52 card deck. Find the probability that you are dealt a queen. Well, that just says a queen. So how many possible queens are there in a deck? 4 out of a possible 52 cards. If you reduce that, you get 1/13. And I think for today, I'm just going to have you write the fraction form of all of these probabilities. So we'll leave that as 1/13. Well, now, how about the probability of not getting a queen? Well, we just found out the probability of getting a queen was 1/13. So if I don't want a queen, we're going to use that formula from up above. And it's 1 minus the probability of you getting a queen. Well, us getting a queen was 1/13. So if I do 1 minus that, that's the probability that I will not get a queen. All right, let's try this with hearts. What's the probability of getting a heart? Well, there's 13 hearts in a deck out of 52 possible hearts. So if you reduce that, you get a probability of getting a heart that is 1/4. Now, if I don't want a heart, I'm going to use that formula that says take 1 minus the probability that you actually do get one. 1 minus 1/4 gives me a probability of 3/4. Now, I hope you notice that if you are to put those two together, you would get 13 over 13, which would be 1. And if you would put these together, you'd get 4 out of 4, which would be 1. Okay? That is true anytime you're using a not probability. All right, so what is the probability you are not dealt a red picture card? Well, if I can find out what's the probability of me being dealt a picture card, I can do 1 minus that to find not a picture card. So, how many picture cards are there? Now remember, picture cards are face cards. So jacks, queens, and kings. Well, I want them to be red. Okay, well, jacks, kings, and queens, there's, 4 of each of those? So that means there's 12 of them. But I only want the red ones. Half are red, half are black. So that means I have 6 possible red picture cards out of 52. If you reduce that, you get 3 out of 26. That's the probability that I will get a red picture card. I want the probability that I will not get that. So 1 minus will give me a final probability of 23 out of 26. All right, let's look at a circle graph, a pie chart now. Use the graph below to find the probability that a randomly selected person is not 20 to 29. Well, if I can find my 20 to 29, I can subtract that from 1. Well, there's 33 million in 20 to 29. Now, it doesn't tell me the total, so you're going to have to go through, and you're going to have to add up all of my total to get your denominator number down there. And if you do add all those up, you should get 191. Now, please check me. Okay, so that's the probability that you will be between 20 and 29. So if I do 1 minus that, that'll give me the probability that I am not between 20 and 29, which gives you that final answer. All right, next up, is less than 80 years old. Well, here's 80 years old. Let's get rid of all this. 80 years old and above is right there. So you can either do that, the 80 years old, and subtract it from 1, or you could go through and add everybody that's not. I think in this case it'd be easier to find the probability for 80-year-olds and then subtract it from 1. Well, it says there's 6 out of a possible 191 for people that are greater than 80 years old. So if I do 1 minus that, the probability that we are less than 80 years old would be that. Again, you could have went and added all of those up that were less than 80, but it might be a little bit quicker to do it the other way. Is at least 20. Well, this group is less than 20. So I can either add up all the ones that are not that, or I can find my probability using that and subtract it from 1. So 9 million out of a possible 191. Subtract that, and you get a probability that will be 182 out of 191. Final problem on this pie chart is going to be is not 50 to 59. So if I find my probability that is 50 to 59, I can subtract it from 1, and I get a probability final answer that looks like this. Now remember, folks, I also can ask you to do the percentage form of this. Okay, so you just divide that and then multiply by 100. All right, mutually exclusive events. If they are mutually exclusive, it is impossible for 2 events, A and B, to occur simultaneously. Meaning they cannot happen at the same time. For example, if you are selecting one card from a deck, you cannot select both a king and a queen at the same time. So that would be said to be mutually exclusive. Okay? Our notation for that, if I want the probability of events A or B, as long as there's no overlapping, as long as they are mutually exclusive, you just take the probability of A plus the probability of B. There's another notation for this. I don't know if you remember, this upside down U means or. As long as the events are mutually exclusive, meaning you can't pick them both at the same time, you are just going to add your probabilities. All right, so one card is randomly selected from a deck of cards. What is the probability of selecting a king or a queen? The first thing you got to ask yourself is, can you select a king and a queen at the same time? And the answer is no. So you will just take your probability of a king which is 4 out of 52, and add it to your probability of a queen, which is also 4 out of 52, and you get a final probability of 2/13. All right, letter B, a 2 or a 4. Can you choose a 2 and a 4 at the same time if you're only picking one card? The answer is no. So the probability of a 2 happening is that. The probability of a 4 being drawn is that. Since they are mutually exclusive, you just add them, and you get your final probability. All right, how about a red 5 or a black 7? Can you draw both of those things at the same time if you're only selecting one card? The answer is no. So you're going to add their probabilities. There are 2 red 5s. There are also 2 black 7s. So you get a probability of 1/13. Excuse me, I'm going to pause this for 1 second and we'll pick back up. All right, folks, let's pick this back up. So remember, we're talking about mutually exclusive, meaning those two things cannot happen at the same time. So can you pick up ace of hearts and a jack of clubs at the same time if you're only selecting one card? The answer is no. So they are mutually exclusive. The probability for an ace of hearts, the probability for a jack of clubs, add them, and your final probability is 1/26. All right, let's talk about rolling a dice. So if I want to roll a 4 or a 5, can I roll that at the same time? The answer is no. So they are mutually exclusive. My probability for a 4, my probability for a 5, add them and you get a final probability of 1/3. How about a 1, a 4, or a 6? Can you roll all that at the same time? The answer is no, not if I'm only rolling one dice. So the probability for a 1, the probability for a 4, and the probability for a 6. Add them all together. And there's a 1 out of 2 chance that you're going to get one of those 3 numbers. All right, last problem here for us. The math department at a local college consists of 8 professors, 12 associate professors, 14 assistant professors, and 10 instructors. If one faculty member is chosen randomly, find the probability of choosing a professor or an instructor. Remember, I'm choosing one person. So can I choose a professor and an instructor at the same time? The answer is no. So what is the probability of a professor being chosen? Well, there's 8 of them. If you add up your total, you would get 44 possible choices. An instructor, there are 10 of them out of 44 possible people. They cannot happen at the same time, so if you add them, you get a probability of 9 out of 22. Associate professors.
We are in a double first period today, so after the speeches, you will report back to your first period class, and everyone will be in first period until the first period classroom until 9:12. So just in case there's some confusion on that. Thanks.
Sorry about that announcement, folks. All right, last question here. An associate professor. There are 12 associate professors out of 44 people. There are 14 assistant professors out of 44 people. They cannot be chosen at the same time if I'm only choosing one person. So for your probability, you will add them, and you get a final probability that looks like that.
In case you guys couldn't hear that last announcement, you are in a double first period today, so after speeches, you will report back to your first period classroom, and you will be in there until 9:12, and then you'll move to second period at that point. So if you already moved your stuff, after the speeches, you'll go grab it, go back to your first period classroom, vote, and stay there until 9:12. Thank you.
Again, I apologize for the announcements. Good Lord. Okay, so your homework now, folks, from this lesson will be please work on that, and I will check that assignment in as well as the assignment that was due today tomorrow when I see you. Thanks, and have a great day.